Hi there, everyone. This is Chapter 19 review. What's that music? That music is me trying to remind you guys that it's the end of the year here, and everyone should just relax. Just take it easy. This is probably going to be one of our last quizzes in this class, so, take it a little more lightheartedly than most people will. I know I'm going to fail it, but you know what? I'm going to glide into it because I find that when I'm relaxed, when I'm chill, I do better on tests. Okay? It's a piece of advice for me, at least. It works very well. I walk in nice and calm. I get, a B or an A. I walk in all stressed out, C or a D. So, if you have bad grades, just try it out. Chill, forget about it, look over the material once or twice, and just let it kind of sit and just relax. Take the day off. You'll have a higher score in no time. So, Chapter 19 is a lot like Chapter 18. It's actually Chapter 18 on steroids. You start off the same way. Check your assumptions for every single goddamn fucking question. Okay, you got your random assumption, you got your independent groups. That's kind of, the same thing as random is saying we have groups because we're dealing with two groups nowadays, not just one. Are these groups both independently selected? Are these two groups less than 10% of the population? And are there at least 10 success and failures in both groups? There you go. Now, instead of working with one group like we were in 18, we're working with two. So, that being said, we have a terrifyingly large amount of calculation functions we can use. 4 of them. Very first one we're going to discuss is the 2-prop z interval. Okay, here is the actual work to solve one of these questions. You're going to be given an n1, n2, p hat 1, p hat 2. And you're going to be given averages. And when I say you're given, he's going to give us most likely, sometimes he'll just give us the numbers, he's most likely going to give us 2 lists, numbered 1 through 10, some random numbers in each list. You have to input those into your calculator, you know how to do that, and then you can find the probability of 1 just by going in the calculator, doing your 1 variable stats, all that kind of stuff from like Chapter 1. I hate how he's bringing it back, but it's coming back. Okay, you get all the information here, and you plug it in to find the standard error. Okay, square root of Q1 over N1. Remember, Q is just 1 minus P. And then you just do that for list 2. And you add them together, and you find your standard error. Mean is just 2 times your standard error. And then, to find your probability of P1 minus P2, you just do X, or to solve this question, you do X, sum X, plus or minus ME. X is just the mean. Okay? Standard, interval notation here. In the calculator, you're going to go to stats, you're going to go to tests, and you're going to go all the way to, it's 2-prop z interval, I missed it, right here, B. Go in there. Now you're going to be prompted with this stuff. X1 is the mean of list 1, X2 is the mean of list 2, N1 is the number of list 1, how many things in list 1, N2 is the number of stuff in list 2. Okay, take it. So say I have 100 people who eat chocolate ice cream out of a list. My list is, say, 100 long. Or my mean people is, say, 89. Okay, let's come up with another one for vanilla ice cream. It's going to be 45. And again, 100. Confidence level 95. I just want them to give me simple numbers. You see, there's my interval. There's my p hat 1, p hat 2, n1, and n2. Boom. Solved. Just put the answer down on the paper. Number 2, that's the 2-prop z-test. Similar to your calculators. The other function that we were discussing a second ago. Sorry, I'm kind of tired right now, because this is like one of the last videos. Test. Okay, you find 2-prop z-test. That's right over here. Look at that, number 6. Press enter. Okay, similar dial-up thing. You got an x1 and x2. Okay, same thing, the mean of list 1, mean of list 2. N1, N2. Okay, then you're prompted with this stuff. I'm going to put not equal to because you're supposed to put not equal to. Calculate. You get your numbers that you need. Boom. Your z-score, your p-value, all this stuff, and more. Look at that. Okay? Here is the actual work. Here's how it's going to look like. It's going to be HO P1 minus P2. Remember to write that down. Equals 0. Always equals 0. P1 minus P2 is always not equal to 0 for the HA. You're going to be given some N1, N2, P hat 1, P hat 2. And to find the z-score, you're going to do this formula here, which is going to be P1 minus P2 minus 0 over the standard error of this stuff. Standard error is right here. You use this formula and just plug it into this one. Not too complicated, just a lot of work. Number 3. Number 3 is the 2 sample t interval. So we're going to close this out, and we're going to find 2 sample t interval. That's further down. 2 sample t interval. Look at that. 2 samp t int. Okay, well, let's click on it. Ah, I messed up. Sorry. Here, 2 samp t interval. 2 samp t interval, right there. Okay, now you can either do this by data or by stats, like last chapter. You can just plug in your lists, plug in your frequency as 1, and boom, pooled yes or no. Are the numbers all pooled into one list or something like that? Click no. Okay, boom, solve the question. Continue, or calculate, or whatever it is. And you'll get your stuff. This is if you have data, okay? You just plug in lists of data. Okay, now we go back, and we're going to pick the secondary option, which is the stats. Okay, x bar 1 is just x1 like the other problem. The standard, mean of list 1, standard deviation of list 1, number of list 1, standard, x2, SD, x, all that stuff, confidence level, pooled, no. Calculate, this probably won't work because my calculator had random numbers. Oh, it did, okay. So, yep, that's all you have to do. You get all this stuff. They ask you for degrees of freedom, x1, x2, x3, x4, whatever it is. Okay. Have fun doing it on this. So, you're going to write it, key distinction. If you're doing a Z test, you do P, okay? If you're doing a T test, you're doing mu, okay? Kind of taking chapters 17 and 18 and like making them both combined and harder. It's bullcrap. Okay, so you have your HA, you have your HO, and it's always, again, equal to 0, not equal to 0. Okay, you could be given a list, or you'll be given stats. Okay, similar formula, except you're doing the standard deviation of 1, of list 1 squared, plus the standard deviation of list 2 squared. Both of them are going to be over their ends, respectively. Okay, and you square root it. That's how you find your standard error. Your degrees of freedom, you got those in your calculator, or you could just do n-1, technically speaking here. And to find your t, you just do y bar 1, which is just your average of list 1, minus the average of list 2, minus 0, over the standard error that you get here. Next, god damn it, list number 4, number 4. 2 sample t test, stat test, 2 sample t test right here. Okay, you're going to be given the same option. You either do data or you do stats. If you just focus that so you can see better. Okay, perfect. Yes, data and stats. Data, you're given the same exact information, except now you're just dealing with mu. Look at that. It wasn't too tough. Stat or data, same thing. List, list, list. Do all your stuff. Pooled, no. Move along to calculated. Okay, you're given these numbers that you need. Okay, he'll ask you for one of them or something around those lines. Okay, how to do it on this. I know this is really a lot of work. So, again, you use mu, and you set mu not equal to 0 for the HA. Now, you're going to need to find standard error, which is the exact same formula as you see here. You're going to need to find your t, which is the exact same formula as you see here. Now, this time, you need to find an observed difference, which is just simply y1 minus y2. This is, again, mean of list 1 minus mean of list 2. And then you need to find your degrees of freedom, which is, again, right here. And it's also given in the calculator. And last but not least, how you're using this is a p-value. Okay? What did I write here? Okay, it's 2p of t. Okay? It's 2 times the probability of some event t occurring. You're most likely going to have to find this t in your calculator. What the hell? Okay, you're going to most likely have to find this in your calculator over here. Where is it? It's 2 samp t test. 2 samp t test. Yeah, and I'm like 95% sure it gives you some letter t. Look at that. Boom. Just 2p of t. So it gives you also a p-value. You just do 2 times p, and that gives you this p-value that you need. Okay, that's that. Okay, what does this all mean? I know this is going to be a really long video, and I'm moving super fast. Watch it twice if you have to, but remember, chill. Chill. Take the test with a calm mind. Okay? What does all this shit mean anyways? This is going to give you an interval, so is this one going to give you an interval. I think this is 3 interval. Yes, these two are intervals. You know what intervals mean. It means that these numbers fall between this interval. There's a 95% chance that this falls in between this interval. Now, what does this stuff mean, the test? Now, notice, this is going to give you a z-score. If the z is greater than 2, you fail to reject, or reject, whatever it is, because it's, you know, outside of that region of that we want. Okay? So, this is similar to what we covered in the last, like, 3 chapters, or whatever the hell it's been. This is different. This is super duper different. This is dealing with the goddamn p-value. Again, you're also going to be, like, rejecting and failing to reject. If it's high, that means there's a high probability that you're going to get this from all samples. If it's low, you're going to get a low probability that you're going to have these in all samples. Meaning, if I have a random sample and I get a probability, a p-value of, say, 0.5, this is actually a really high p-value, meaning we fail to reject. Okay? However, if it's below 0.05, this is the magic number you're looking for. If it is below, I'm going to draw an arrow to make sure you understand that. If it is below 0.05 p-value, that means that there's such a small chance that you will get the same result from another test. Okay? If it's below this, it means that it's such a small chance that you have to reject the null. Meaning, simply, if I have a sample here and I get some number, okay? This p-value gives me the chance that if I selected some other sample here, it's going to give me the same result. You understand? So low p-value is bad. That means that any other sample is going to be different. A high p-value is good. That means if you pick another sample, chances are it'll be the exact same. Okay? So remember, 0.05. I can't stress it enough. This is the most difficult chapter I've had to do. I barely know half of this stuff. I'm learning it is pretty much at the same time as you are here. I mean, this is like my 3rd time reviewing it, believe it or not. So, with that being said, just play your cards right, relax, go in cool-headed, and you'll find that you'll remember a lot more of this information because, surprisingly, this time around, I don't think he did such a bad job explaining it, Mr. Farmer. He actually did a pretty decent job, just I was out for a day yesterday, and, well, here I am, right? Don't forget to do the worksheet. Good luck. Just overall, remember, chill, relax, don't stress out. Just review all this information once and just let it settle in your brain. Watch some TV, relax, hang out with your friends. Whatever you want to do, I don't care. Just try it out. If you've been failing the past couple of tests, just try going in smooth sailing. Take it in stride. All right? Good luck. Bye.